Hey guys, it's Mr. Vines with your lesson 2, unit 5 answer video. Woo! Intro music! There's no intro music. It's math. Come on. Come on. Okay, so for this lesson, um, we are doing kind of function and building the foundations of what a function is and how rules are involved in building a function. And so the standard is still the same from last time. Understand that a function is a rule that assigns to each input exactly one output. And I want you guys to know at the end of this lesson, I know that a function is ruled exactly one output for each allowable input. I know that if a rule has exactly one output for each allowable input, then the output depends on the inputs. Okay? And that's where we'll be coming today. But before that, my warm-up is on the substitution method. For the substitution method, we talked about this. If they're both in y equals mx plus b, then all you do is set them equal to each other and solve. Right? And you solve. So you're going to set them equal to each other and solve. So you're going to add 2 to both sides. 4 equals 8x minus 20. Add 20 to both sides. 24 equals 8x. Divide by 8. Divide by 8. 3 equals x. Okay. So once again, we're going to add 4 on both sides, add 2x on both sides to get ax minus 20. And then we're going to add the 20 on both sides to get 24 equals 8x. And then we're going to divide by 8 on both sides and get 3 equals x. Okay, so for the next problem, we're going to be looking at different type of substitution. You can see that here I substituted this y here with this y over here, which equals x minus 5. So this y right here becomes x minus 5. And then you just solve the equations. You see there's 3 terms there? There's 3 terms there. So you're going to combine like terms. Negative 2x minus 5 equals 11. You're going to add 5 to both sides. Negative 2x equals 16. No, that's a negative 11. So it's going to be negative 6. Divide by negative 2 on both sides, and you get x equals 3. So let's write that down. So combine like terms was this step. Then we're going to add 5 to both sides, you get negative 6. Divide by 2 on both sides, and you get x equals 3. Okay, so now from here, we want to determine the rule for each table. So remember that rules, so what happens is that 15 goes in, and then there's a rule that's done to the 15, and then out goes 5. And then negative 5 goes in, there's a rule that happens, and then out goes negative 15. So you can see that this would be subtract 10, right? And then the rule is, so yeah, the rule is subtract 10. You take the number and subtract 10. So 3 minus 10, negative 7. 10 minus 10, 0. So now for this one over here, it looks a little strange because it's a bunch of 3's, right? So think about it. A lot of people thought about this right here, was you multiply by 0, then you add 3, which is a good mathematical rule. Or you could just think of it like this. You could think of it like the output is 3. You can think like that too. The output is just 3. The output is always 3. Y is always equal to 3. Okay. But so that's it for the warm-up. Going on to 2.1, what is a function? Okay, guys, so we're going to be doing what is a function 2.1 now. Rule number 1, rule number 2, rule number 3 are called functions. Rule number 4 is not a function. So you can see rule number 1 the rule is to add 7. You can see all the inputs have been added 7 to get the output. For rule number 2, it's divide by 4. For rule number 3, it's times 0, add 3. Rule number 4 is not a function. So this is not a function. So these first 3 are functions, and this is not a function. So here, down here, I want you to finish the sentence. Blank makes a rule function. So based on these 3 tables that are functions and one that is not a function, what makes a rule a function? Okay. And then put it whatever. There's no wrong answer as long as it has some basis and logic. Okay, guys? And then I'll tell you what actually a function means, okay? Okay, so you should have been writing what you think makes a rule a function here. And now actually a function is a rule that assigns each input to exactly one output. So the rule has to pair things together and only that one thing. They're exclusively together. They're boyfriend, girlfriend, just together. Okay, that's what it means. So the rule has to pair one thing to another thing, not two different things, just one thing. So dividing by 2 would be a function because there's only one way to divide by 2. There's not multiple ways to divide by 2 there. It's one way. And so there's one answer. So like 10 divided by 2 is 5. It's not any other answer but 5. So the rule has to produce just one answer for each number that goes in. So we're going to highlight each table of values that represents a function. So when I'm trying to figure out what represents a function, I will look at the function, see if I can solve if there's a rule happening. And if there is a rule happening, I'm going to check to see if that rule produces one input for exactly one output. So let's look at this. Okay, guys, so for this one, to highlight each table of values that represents a function, you want to look at it and see if there's a rule, like I was saying before. And so if you look at this rule, you can see that this rule looks like you're dividing by 6 for each of the inputs to get the output. 54 divided by 6 is 9, 30 divided by 6 is 5, negative 18 divided by 6 negative 3. So this would mean that there's only one way to divide a number by 3, so there's never going to be an input which gives you 2 outputs. So this would be a function. Over here, you can see that the rule looks like to be negative 3 equals negative 3, negative 2 equals negative 2, 0 equals 0, 0 equals 1. But if you look at these two right here that are highlighted, that rule doesn't. This 0 equals 1 does not kind of obey the rule of like whatever goes in goes out. The same thing goes in, the same thing goes out. That's kind of the rule. But 0 does not equal 1, so that wouldn't be a function because it doesn't have the rule that applies there. And so I wouldn't highlight this one. So for this one down here, I also kind of pointed out that the rule looks like it's multiplied by 9. So multiply by 9. 9 times 9, 81. 6 times 9, 54. 3 times 9, 27. 3 times negative 27, what? 3 times 9, negative 27? So no. So this doesn't make sense. You have the same input has two different outputs. And so this rule, this second 3 doesn't obey the rule. So this would not be a function. So that'd not be a function. And you can see over here, it's the same thing. 4 becomes 2, negative 8 becomes 4, 10 becomes 5, 120 becomes 60. It looks like it's divided by 2. But this second negative 8, is divided by 4, which wouldn't match the rule that's kind of everything else going by with. So this wouldn't be a function, so we don't have to highlight that one. And then over here, you can see that we're looking at it. Negative 2 becomes 3, negative 1 becomes 4, 7 becomes 12, negative 20 becomes negative 15, 7 becomes 12. So you can see there, it looks like this looks like they have the same input here, but they have the same output. So, and they still obey the rule of +5. So this would be a function. Even though there's the same input is repeated twice, it has the same output. So that means that every input has one output. There's only one way to add 5. So now for the last one, -5 becomes -10, -1 becomes -2, 2 times 2 is 4, 5 times 2 is 10, 6 times 2 is 12, so it looks like it's times 2. There's only one way to multiply by 2, so that means that for every input, there's one output. Okay. So our last section is 2.2, equations as functions. So we can represent functions with equations. For example, a linear equation in the form of y equals 3x minus 4 is a linear function because for every output there is one input. We can also draw a diagram to represent this function. So the diagram would be x goes into 3x minus 4, and out comes y. So you're going to multiply by 3 and subtract 4 for each of the different inputs. And so now, in this case, we think of x as the input and y as the output. For example, 3x minus 4 equals y. That's how I like to see it, the other way around. So it makes sense to me that in goes, because we read from left to right, but in math, it goes from right to left, kind of. So left to right, you plug in the x, you multiply by 3, subtract 4, and that'll give you the y. And you can see I've done that for each one of these. I've taken my input, I multiply by 3, and I subtract 4 for each of these. Now, the x is called the independent variable. The independent variable is what you can choose and what you can put in. Y is called the dependent variable because you cannot choose what comes out. The the equation decides what comes out after you put in the input. So that's how we see it in that way. Okay. So let me give you some examples of how to do this. So now we're going to complete the table based on the given linear equation. You can see I already have an example for you there. And what I like doing with these ones is I like to do my work on the side, right? So what this means is that 2 times x minus 1 is equal to our y. So we're going to be replacing this x with our different inputs. So our first input we want to do is 3. So 3 times, so x becomes 3. And so you're going to have 2 times 3 is 6, minus 1 is y, 5 is equal to y, right? Now, -3 times 3 plus 2 is equal to y. So -6 plus 2 is equal to y. So -4 is equal to y, right? That's where we're kind of do. -4 is equal to y. Where did I get -4? Oh, nope. This would be 9. And that would be, so when it's -3, so when it's 3, I'm looking at the wrong one. Let me erase that. I went ahead, right? I want to do the 0 one. So now, for the last one, for the next one, you're going to have 2 times 0 minus 1 is equal to y. So 2 times 0 is 0, minus 1 is just going to be left with -1, right? So that's why I get -1 there. And so from there, that's how we do it. So you're just kind of plugging in, and you're doing the operation that's there. So for this one, this means that in order to get the output, you're going to need to subtract. You're going to need to multiply by -3 and add 2 for this one, for each of these inputs. So here, -3 times 0 is 0, plus 2 would be 2. So here, -3 times -3 would be 9, plus 2 would be 11. -3 times 10 would be -30, plus 2 would be -28. And then negative 10 times negative 3 plus 2 would be 32. And then negative 3 times 2 plus 2 would be negative 4. Okay. So this one says that you're going to take your x and you're going to multiply by half, which is the same thing as dividing by 2 times your x. Okay. So half of 4 is 2. Half of 0 is 0. Half of negative 6 is negative 6. And then half of negative 2 is negative 1. Half of 2 is 1. For this one over here, you're going to have 1/3, same thing as dividing by 3. So you're going to divide your x by 3, and then you're going to add 3. So 1/3 divided by 3 is 1. 1 plus 3 is 4. And then, so this would be just plus 3. So it'd be 0. Negative 3 times 1/3 would be negative 2. Negative 2 plus 3 would be 1. Negative 3 divided by 3 would be negative 3. Negative 3 plus 3 would be 0. And 12 divided by 3 is 4. 4 plus 3 is 7. Okay. And so the rest is kind of our summary. You can read those on your own. You can check out the GIF too I made at the end. That kind of represents our equation. Right there, see? Right? So check that out. Make sure that you're doing your homework and checking everything else. I'll see you guys later in class.